And we talk about I think on last Thursday we talk about page 42, and I did not talk about page 41. Now we go to page 41. Okay, so we have after talk about the supports. Remember that after we talk about the supports, then we talk about equilibrium. So we have we have two special cases. And the first one is called two-force body. If you look for the Chinese term, it is this one. And for this one, that's for a two-force body. Wait a minute. And what is a two-force body? A two-force body is a rigid body. It's a rigid body where external forces act on 2 points. External forces act on 2 points of the body, which means, for example, this is a two-force body where this one is a two-force body because all the forces are acting on A or on B. Sorry. So let's say we have, for example, we have F3 and let's say F4 and F5. Is this a two-force body? This is a two-force body because all forces act on 2 points of a body. Okay. All forces act on 2 points of the body. Sorry. Act on 2 points of the body. So all forces act on A or act on B. So this is a two-force body. It's okay. Now, and let's it's okay that I will clear this. Now, let's say we talk about an example here, and if rigid body AB is in equilibrium, so we have one force F1 acting on point A, and we have another force F2 acting on point B. We have two forces, and one is F1 acting on point A, the other is F2 acting on point B. So let's consider equilibrium. So if we have summation F equal to 0, which means we have F1 equals to minus F2. We have two forces, F1 is this way and F2 this way, right? F1 going to the left and F2 going to the right. This is easy. And how about summation M equal to 0? Let's say we take A as point of reference. Okay, we take point A as point of reference, and so we have what? And this is so this F1 will not have a moment arm, so it will not moment. And for B, the moment arm of this F2 is R B with respect to A, right? And then we have so I think we are doing scalar, right? And then we have the magnitude of F2, and then we have the angle between R and F. In this case, R and F, right? So it has to be equal to 0. It is equal to 0. Okay. So what do we have here? So why is it equal to 0? Let's look at it one by one. So is it equal to 0? Is the moment arm RB with respect to A equal to 0? No, it is not equal to 0. So does F2 equal to 0? F2 is has a force because F1 is equal to minus F2 and they have the same magnitude. So this one does not equal to 0. So what do we have? So we have sine theta equal to 0. So which means theta is equal to what? What does it mean by sine theta? Sine theta equal to 0. So 0 degrees or 180 degrees, okay? So it means this angle has to be 0 degrees or 180 degrees, which means that F1 and F2 are on the same line of action, which means F1 and F2 must have the same line of action. So actually, this line of action is going through AB. And of course, they have the same magnitude and they have opposite senses. These are easy. And the key point is they have the same line of action. That they share the same line of action. Is that okay? If all the forces act on 2 points of the body, sorry, let me go to here. If all the external forces act on 2 points of the body, then these forces have this specialty. And remember, in a two-force body, there should not be any couples. Okay. So if, for example, if we have F1 and F2 and suddenly we have MP here, that this is not a two-force body. Because we have a couple here. Okay, and we are talking about for a two-force body. We are only talking about it has only forces acting on the. We have only forces acting on the body. We do not have moments here. We do not have moments. Oh, okay. Okay. Oh, this one, absence. Absence means okay. So absence means 不在. And if you look at the dictionary, actually absence also means if you look at the dictionary, that the absence usually means 缺席 in the so here that absent means we do not have moments. We do not have couples. Okay. A very good question. Now this is two-force body, and based on that two force body, we have another type of special problem we call free force body. So what do we mean by free force bodies? Free force body means forces are acting on. Wait a minute, sorry. And acting on 3 points on the body. Okay, we may have many forces, but these are all forces act on 3 points of the body, like A, B, and C here. Now, sorry, have you copied this or? Yeah, thank you. Now, and we make it bigger. Let's go to the right hand side. Let's go to the right hand side figure here. Now, let's say we have because we have a rigid body, so we have transmissibility. So this force F2, and we look at these two first. And so for this force, and for this force, the F2, we say we have the line of action BD. And then we have an F1 line of action AD. What can we do from here? We move F2 to here. Okay? We move the force from F2 to here, and we move the force F1 to here. F2 here, F1 here. Is that okay? We move to here and we move this to here. So what do we have? After we move this to here and move this to here. So F1 and F2 act on D and F3 act on C. So what do we have now? We have a two force body. With point C, we have F3 acting on point C, and what do we have acting on point D? F1, what else? We have F1 acting on point D and anything else? I don't know. F2, okay? So, and what we learned that for two force body, that these two forces should share the same line of action. CD, right? We have just learned from two force body that they should share the same line of action. Up to now, we have just said that F1 is have the line of action AD. F2 has the line of action BD, and we did not say anything about. We did not talk about F3, right? But from here, we know that F3, the line of action of F3 is CD. Is that okay? Now we go back to the left-hand side figure. We go back to the left-hand side figure and draw it here. So we have line of action AD here, BD here, and we have line of action CD here. We have line of action F1 is AD, and line of action F2 is BD, and line of action F3 is CD. So it says, for example, that it means the three lines of action would not go this way, okay? The lines of action will not go this way. The lines of action will not go this way. The lines of action will always intersect at one point. Okay? It will not go like forming a triangle inside in the middle, but it will always intersect at one point. So this is what I write in the bottom. Sorry, I'll go back to the picture. So if the three force body is in equilibrium, the lines of action of forces must intersect at the same point. It's okay. For a three force body, the force acting on C, force acting on B, and force acting on A intersect at the same point. It will not go like this one in the triangle. It's okay. Now, I want to talk about. Now it's 2:45, and let's talk about the question I've just given you today. Wait a minute, and I think it is this one. Just give me a minute, and right, this one, 483, and anybody not having that? And for those, and you can get the PDF from iLearning, and I posted the link to this page on iLearning. Now, rod AB is bent to a circular arc, and is supported by pegs. Pegs should not be there. And D and E. So we have supported by pegs and D and E. Now, and load P is acted on the arc at point P, and neglecting friction and the weight of the rod. Determine the distance C correspond to equilibrium. It's okay. So so we have a rod ADEB, and then we have a force here, and then we have support forces here. Now, how to determine this C? Let's draw the free body diagram. I've given you the dimensions. I've given you the contour. So what you need to do is to mark the forces. So for neglect is so we have forces and where do we have? Of course, we have a force P here at point B, and where do we have the other forces? So because for equilibrium we must summation F equal to 0. Where do we have the other forces? Do we have forces in A? Do we have forces in A? Where do we have the other forces? Do we have forces in A? No. And do we have forces at D? Yes, because it's supported at D and it's supported at E. So we have two forces D and E. So we have forces as D, E, and B. So this is a what? Free force body. This is a free force body. And for a free force body, all the lines of action of free force body should intersect at the same point. So for the line of action of P is here, and let me draw here. So and the force of action, lines of action of forces D and E should go to the same point. Okay, go to the same point somewhere, and these three forces should have the same line of action. It's okay. So the problem now is where, and the problem now is where. So would it be here, or would it be at point C, or whether it is point somewhere above? Okay. The only question is where do they intersect? Here or somewhere. Now, these are the pegs and these are rollers, of course. So in which direction should we draw the force? So can this rod move in this direction? Can it move in this direction? This is you can say a roller joint. Or we do not have friction. We do not have friction. So it can move in this direction. Can it move in this direction? No. So we draw a force. So this one is okay, and this one is NG. So so the force here is going to going towards point C. So this one is have a right angle. It's okay. The same logic goes to point D. Because of the arguments here. Because what I've explained here. So it can move in this direction. So it does not have forces. It does not support forces here, but we cannot move in this direction. So we have support forces in this direction. This one is this one is tangent and this one is normal, right? Oh, sorry. I've explained what is tangent and what's normal, right? this one is normal, and this one is tangent. So we have normal forces here and here. So these three forces, the lines of action of these three forces intersect at point C. It's okay. Now the problem goes to what are the angles of these two forces, and what are the magnitudes of and what is C here. Now, and to be, if you believe in me, so and we say let's take MD is equal to 0. MD is equal to 0. So, and E is if MD equals 0, so this goes clockwise, and because for force at E, it only goes either here or there. Okay, here or there. So, do you think it's going up or going down? Because B is going down, so E is going up. Okay, so so E is going in this direction. So let's draw it here, E here. And because E is going up, so that D is going down. The only problem is so how should we go? How should we go from here? And we know D is going down and E is going up. But we don't know the angles, right? We don't know the angles yet. We don't know the angle of this one. We don't know the angle of this one and this one, right? We have quite a lot of unknowns here. So what should we go from here? We determine the angles. So the first one we determine the angle. So what is this angle, this angle, this angle, or this angle? So the first one we determine is and we first determine this one. And how should we? Let me write alpha. What is alpha? Alpha is 45 degrees. So, and of course, angle HCB is also 45 degrees then. This one is, let me mark it here, 45 degrees, right? Because this one is right angle. It's okay. And now we have we need to determine these three angles, because if we know this angle, that we know C, but of course we need to determine this angle first. Determine this angle first. Now, and next we have we need to determine this angle, because this one is equal to, let me write it down. And we know this one is equal to R and this one is equal to R, right? These two are equal to R. And we know this, we sort of know this because this one is 20 millimeter, this one is 20 millimeter. So this one is, and EH is, because this one is 45 degrees. So we know EH is equal to half of ED is equal to 20 times 0.707, okay, millimeter. And we know, and CE is equal to R is equal to what? To 100 millimeters. So we know, let me mark them down. So we know EH and we know CE, right? We know EH and we know CE, and therefore we know this angle beta, and and this is HCB is equal to 45 degrees. So we know beta, right? Beta is, how do we determine beta? We know this and we know this, and how do we determine beta? We know this one and we know this one, and how do we determine beta? Sine beta is equal to, sine beta is equal to what? And 20 times 0.707 divided by 100. And so beta is, let me give you the answer, is equal to 8.13 degrees. So we have this angle equal to 45 degrees minus beta, and sine 45 degrees minus beta is equal to C over 100 millimeter. So C is equal to 60 millimeters. So all of this is geometry. But we make use of the property of free force body here.